Hey everybody, this is Miss Moran again. We're on Unit 7, Video 4, and we're going to be working with graphs and applications with e to the x. So we had an introduction in class on what is e and how we will be using it, and today we're going to get to graph it, and then we will also get to apply it in one of a few situations. Alright, so this is my basic graph, or my parent function. This is going to be the parent graph. And that is just f of x equals e to the power of x. So we're going to go ahead and use our graphing calculators to help us with this because it'll make our calculation life a little bit easier. So go to y equals and you can enter in e to the power of x. There are two places you can find e on your calculator. The first place to find e on your calculator is to the left of 4. And if you do that, you'll just go ahead and hit second, and the button says ln, which we're going to use later this chapter, and it gives you e, and it opens up the parentheses for you to put the x in for your exponent. You may also use it, it's above the division sign, and you would just use second e, but there you have to apply the caret and then put in your exponent as well. So either way, you'll get exactly the same answer. And you can close your parentheses if you'd like around that. Alright, so now you want to go ahead to look at your graph. Now if your table isn't set up to autofill, the way to turn back on the autofill for your table is to go to second window and make sure that both the independent and dependents are on auto. So once again, if you need to change your window or your table so that it automatically fills with all of our values, you go straight to second window and change those both to auto so that it automatically fills. Return to your table, and we're going to pick some points that we can graph. So none of these, or very few of them, like if you look, 0 gives us a nice value, so we're definitely going to do 0, 1. But many of the other ones are not going to give you a very pretty decimal to graph. So these are often going to be approximations. So let's pick a few that are on the negative side. How about -2, 0.13534. So -2, and we're so close, we're right down there. Okay, and then, so this gives me this point. And then let's go to -1, where we're almost at 4/10, so we'll go a little bit closer to halfway. And then we'll go on the other side. Now, e to the 1, e to the first power, gives us our value of e, which was our 2.7183, etc. So we definitely want to put this on there, 2.7. And then for, let's do x equals 2, which gives us 7.38. So 2 gives us 7.38 right there. And then the rest appear to be off of our chart, or off of our graph. Now, these values over here actually don't ever touch 0 as we move in the negative direction. They don't ever touch 0, but they do actually continue. So you must have an arrow on both sides of this. So as we head towards negative infinity over here, kind of our end behavior idea, these are actually going closer and closer and closer to 0. Will they ever go below 0? Will this ever cross this? Well, on our parent graph, it will never cross our x-axis. That helps us with our domain and our range. So it looks like no matter what, you can put positives, negatives, 0, all of those are in our domain. So our domain here is all real numbers, or from negative infinity to positive infinity. But our range looks like it's never going to be 0, but it goes all the way to positive infinity. So this would be y is greater than 0, not equal to. My asymptote. It appears that my asymptote is going to be y equals 0. Okay, and that's where this will get very, very close to here. Okay, as we go close to the x-axis. And my y-intercept looks like positive 1. So I will have an intercept at 0, 1. That's our parent function. Let's try the next one. All right, for this one, we're going to have some changes. There's some transformations that have occurred. So let's see what we can draw some conclusions from this. So go ahead back into y equals and go ahead and try to graph the next one. So you're going to enter this, and you must include this entire exponent in parentheses, and you have to close the parentheses before you do the -2. And let's take a look. You can even look at the graph of that one if you'd prefer to look at the graph first, and you can kind of see what had happened. Compared to the parent function, our graph looks like it has been shifted down, and it looks like it's been shifted left. That shouldn't be surprising based on all the transformations that we've done this year, where inside of the parentheses with the x, we have a +3. It went left 3. And then we have, over here, we went down 2 with our -2. Let's return to the table, and let's pick some values. Now, since it went left 3, I probably want to look a little bit more in the negative direction to pick up a couple more points. And since it went down, I expect to see some points below our x-axis. So I'm actually going to start all the way out at about -5. So at -5, I'm graphing -5 is all the way out here, and I'm going to graph -1.865. So -1, -1.8, and then I'm going to graph -1.632, and then I will graph -1 for this point. And then I'm returning to the positives after that. So I'm at 0.71 for -2. And I can continue. And at -1, we are at 5.3. 5.3. And by 0, I'm all the way at 18. So I'm exaggerating up here, or under-exaggerating that my 18 is up here. Okay, so just by that, I'm actually going to go ahead and fill in my y-intercept is 0,18. All right, let's go ahead and connect these and see if we can draw the rest of the conclusions about this graph. Whoa, I overshot that. I'm going to erase it. Try again here. All right, so there's my graph. And it crosses the the y-axis at 18. All right, so let's take a look and see what happens. My domain. What is my domain going to be? Well, it looks like I probably can still substitute in every x value I can imagine. Positives, negatives, it doesn't matter. Because when I use my negative x values, I just got values down here. So my domain is still all real numbers. My range. Well, my range is dependent on what my asymptote is, and I have a horizontal asymptote down here at y equals -2 because it shifted down 2, which makes my range everything from -2 to positive infinity, not including, so another way to write that would be y has to be greater than -2. Okay, so my transformations work very similar to the other functions we've worked with, where the inside number here will affect my x, my horizontal shift, and the number after that will affect my vertical shift. Okay. Now we're going to go ahead and try one of many applications that we can use with E. We're going to be talking about more together in class the next time. So let's read this one. Future amounts of atmospheric carbon dioxide measured in parts per million, our ppm, may be increased according to the function f of t equals 353 e to the power of 0.0060857 times t minus 1990, where t is the given year. Use this model to approximate the atmospheric carbon dioxide in year 2000. So this really just comes down to very careful entering of all of this information. So we're going to start by typing on your home screen 353 E, and then you can use the caret and open it, or if you use the one that's by the number 4, it opens it for you. Very carefully typing in 857, and then use the multiplication symbol. And you are more than welcome to open another set of parentheses if you want to, but since I'm substituting in 2000 minus 1990, I'm going to go ahead and just say, well, let's multiply by 10, and then close my parentheses. Hit enter, And then we will find the amount of atmospheric carbon dioxide in the year 2000. So we have F of 2000 equals approximately 375.15 parts per million. And that is our answer. All right, so you have a worksheet that you need to work on to finish this up. And I would like you to make sure you log into the Schoology class and take the quiz that's titled Unit 7, Video 4 Entrance Slip. And then after, just so you can recap, after this lesson you should be able to graph our exponential functions that have a base of e and use an equation, so kind of evaluating some applications when we substitute in some numbers. All right, thank you very much.